Hello learners, Mr. G here, and we're going to be making a video that is an activity, a question related to conservation of charge and charge quantization mostly. Okay, so in previous video we did one on conservation of charge, and we did a video on charge quantization. Okay, we make those two videos. So let's now relate the two concepts into a question. This question says two small identical conducting spheres are suspended on long silk threads as shown in the diagram. So you have two spheres that are charged Q1 and Q2, and the charges of Q1 is positive 3 nanocoulomb and the charge on Q2 is negative 2 nanocoulomb. Now remember, you cannot work with nanocoulomb. So let's somehow convert right in here in the same picture. Q2 is going to be equal to minus 2 times 10. Remember, nanocoulomb is going to be times 10 to the minus 9 coulomb. And this one is a Q1, which is equal to positive 3 times 10 to the minus 9 coulomb. So sometimes we have to work with these coulombs and non-anode coulomb. Okay. Now the question 1.1 say calculate the number of electrons that were transferred to Q2 to acquire a charge of minus 2 nanocoulomb. So for charge Q2, so let's write a solution here and then let's start solving that equation. Okay. Solution. This is 1, 1.9. So is data. What do we have? Q2 is equal to 2 times 10 to the minus 9. Negative 2 times 10 to the minus 9 coulomb. We need the charge of one electron, or the elementary charge, which is equal to 1,6 negative times 10 to the minus 19 coulomb. Okay, that is the charge of electron, and we're looking for the number of electrons that have this charge in excess. Okay, using charge quantization, we have that charge is equal to the number of electrons, or the elementary charge, multiplied by the charge of one electron. And in this case, we use the symbol of small q, but doesn't matter. It's not really a big problem. The charge is equal to minus 2 times 10 to the minus 9 coulomb, and this is equal to Ne multiplied by minus 1,6 times 10 to the minus 19 coulomb. So the charge of one electron, of the number of electron, pardon, is equal to 1,25 times 10 to the 10 electrons. This is the number of electrons that sphere have in excess. Okay, so that is question 1.1. Let's go to question 1.2. Now, the question said the spheres now moved. They moved, obvious, you know they will move because they are on threads. Okay, now describe in your own word the sequence of events that will occur. So there are mostly 3 events that is going to happen. What will happen first? Well, the first thing that will happen is that the spheres are going to move toward each other. Why? Because they are opposite charge, they are positive and negative, and opposite charge attract each other. So that is the first thing you have to write for the answer. So let's go here down to question 1.2. Alright, so what is first going to happen? First, the charges will move toward each other. Charges will move toward each other. Why? You don't have to explain the why, you have to explain the event, but let's say why are they moving towards each other? Because they are unlike charge. They are unlike charge. And unlike charge, let's fix this word here, the writing quickly and make mistakes. Unlike charges, attract each other. Okay, that is the first thing that is going to happen. Second, what is going to happen when the spheres are touching each other? Okay, electrons are going to transfer from one sphere to the other. Okay, so let's go to that part of the question here. So here, what is going to happen? The two spheres are touching each other, and then electrons are going to move from the negative to the positive. Electrons are moving. The charge will rearrange. This is, remember, the conservation of a charge. In a closed system, remember the system are the two spheres here, the total amount of charge will be conserved. So the charges will rearrange now here from the negative to the positive. So that is what you have to explain. So second, the electrons are transferred from Q2 to Q1. That is important. Remember, this one is Q2 and this one is Q1. It does not really matter the capital Q or the small q. And third, what is going to happen third? Now the two charges will acquire the same charge. The charge is going to rearrange and they will have exactly the same charge. Therefore, they will repel each other. So, third, the charges will repel each other because now they are like charges. Will repel each other. Okay, so third, the charges will repel each other because they will have like charges. We are not going to say what charges are they going to have because that is going to be the third question. Calculate the number of electrons that were transferred during the event described in question 1.2. During this event of touching, during this event, you have to calculate the number of electrons that were transferred. Now, this question is a little bit tricky. It is there with that purpose of being tricky because now we need to know what is the number of electrons that were transferred from Q2 to Q1 while they were touching. Okay, so let's see what we have. Let's write first of all the data. Okay, what we have the charge of Q1 and the charge of Q2 before they touch. This is before they touch. So before touching, this is the charge. What happened? When they touch, the charge will rearrange and is different. So we have to calculate the new charge. We need to calculate the new charge of those two spheres when they touch. So Q new is going to be equal to Q1 plus Q2 divided by 2. And that will give us the final charge of each sphere. So Q1 is equal to positive 3. You can work in nanocoulomb or you can work with coulomb. It does not really matter. Let's work in nanocoulombs and then we convert it, the final answer. Plus Q1 is minus 2 nanocoulombs divided by 2. Okay, divided by 2. So this calculation is going to be equal to 0.5 nanocoulomb. So this is the charge of each sphere after they touch. Okay, so the charge, let's write here, the charge of Q1 is going to be equal to, and both of them are positive, positive. It's equal to positive 0.5 times 10 to the minus 9 coulomb. We are converting. Charge 2 is equal to positive 0.5 times 10 to the minus 9 coulomb. And this here is going to be after. This is after they touch. So we have a before they touch and we have an after they touch. We want to know the number of electrons that were transferred from before to after. So to calculate that number of electrons, the first thing we need to do is to calculate now the second thing. The first thing was to calculate the new charge, and the second thing is to calculate the change in charge. How much that charge change. So how do we calculate the change in charge? Now, the change in charge, like any change in physics, is going to be equal to final charge minus initial charge. Remember, change is going to be always final minus initial. So the final charge here, it could be any of this one. Okay, let's say, for example, let's use Q1. For Q1, okay, change in charge for Q1 will be, what is the final charge of Q1? Here it is 0.5 times 10 to the minus 9, and then minus the initial Q1 is a positive 3. So minus 3 times 10 to the minus 9 coulomb. And this is going to be equal to negative 2.5 times 10 to the minus 9 coulomb. Or you can also do it for Q2. You don't have to do it for both. I just doing it to see that it's the same answer. You can either one of them, you can use either one of them. Okay, so change in charge 2, remember we're working with 1 here, here with 2 is equal to final charge, which is here 0.5 still, 0.5 is the final for both of them, minus the initial that was negative 2, minus initial is negative 2 times 10 to the minus 9, and this is going to be equal to, positive 2.5 times 10 to the minus 9 coulomb. You can see that the final answer is the same. The change in charge is the same. One is positive and one is negative. The negative one is because acquire now more electrons than before, and the one that is positive is because loses electron. So then when you have this, either of them, please, I just want you not confused. You don't have to do both. You calculate for either of them. And then using this one, you may calculate the number of electrons that were transferred with the same formula of charge quantization. So let's do it here for Q1. You have that charge is equal to number of electrons multiplied by the charge of one electron. So number of electrons is equal to the charge divided by charge of electron. Let's substitute here, and then we have that the charge is, remember we're using with the change in charge, so this one is the one that is coming here because we're looking for the number of electrons that were transferred, that changes. So this one is equal to minus 2.5 times 10 to the minus 9, because this one have now more electrons, divided by 1.6 times 10 to the minus 19 coulombs, and this, the answer will be 1.56, sorry, 1.56, sorry with that, I don't know what I pressed there, times 10 to the 10 electrons. So this is the answer. This is the number of electrons that were transferred during the process. And if you want to use charge 2, is also going to be the same. We're going to write number of electrons is equal to charge. This is not charge 2. Remember, in this case, this will be the change in charge. And then you use positive 2.5 times 10 to the minus 9 coulomb divided by, now this one have less electron. So instead of using charge of electron, we're going to know how many protons does it have extra. All right. So this one is equal to 2.5 times 10 to the minus 9 divided by 1.6 times 10 to the minus 19. We're using positive because it is positive. And the answer will be 1.56 times 10 to the 10 electrons. Okay. I hope it's clear. This question is tricky. Is a lot of work. You can go through the video. The advantage of the video is that you can always pause the video, go back, look what you didn't understand, redo the calculation, and I hope you understand. This is not going to be in the past test. The past test is past, but for the upcoming exams, it will be a question like this, and this is applicable for grade 10 11 and 12. It is very, very important. Okay, thank you for watching. If you think it helped, then thumb up. You can ask questions, you can suggest, and good luck.